Hello everyone and welcome to Working with Sitecore in Containers. The idea of today is to take us through how we can utilize Sitecore when working in the new realm of containers. So the things we're going to look at today, we'll give a quick introduction to myself and then a very quick start to how Sitecore works inside of containers, the community project around Sitecore in containers, and how you can get up and running as soon as possible. Then we're going to just look at how we can adjust our mindset, how we can change our thinking for containers. They're very similar but require a subtle adjustment in how we think about things. And finally, we'll talk about what's next. What are the new things that you're going to be seeing in the next versions of Sitecore? So my name is Stephen Pope. I am an architect at Sitecore. I'm from Bristol in the UK. I've been with Sitecore a very long time, 8 years. I've been working with Sitecore for about 13 years now, so I know all the sort of ins and outs. And if we take a current look at the state of the Sitecore community, it pretty much looks like this. Everyone is going absolutely crazy for Docker. It's Docker this, Docker that. There's some wonderful blog posts and community posts and series of blog posts all about how to get up and running with Sitecore on Docker. We have customers going live with a containerized version of their application. And it's really, really great to see inside of the community. So what I wanted to talk about was not what Docker is, what containers are. I'm going to assume that you have some introduction to what Docker is. You know what the idea of a container. What I really want to focus on is the subtle changes, all of those things that you're sort of doing day to day, and how those things are slightly modified when you're working with Sitecore when it's inside a container. The other thing I'm going to focus on today is the Sitecore Docker images repo. So this is on GitHub. You can go now and download the packages from this. And this is a community supported project. And the idea of this was we had lots and lots of different MVPs, companies all working in different ways to deliver Sitecore into Docker. It's a really sort of popular way of delivering Sitecore, lots of innovation and other things within that sort of space. So we're finding that there were lots of separate efforts to do this. And what we wanted to do was pull all of these things together into one place, which meant that people from different companies, different MVPs, etc., could all pull their resources into one thing. And we had a really good sort of community effort put together for it. And this is why we have the Docker images repo. And a lot of what I'm going to talk about today is about the features and the functionality that we find inside of there. This is a sort of non-official official Sitecore repo. It's under the Sitecore name, but it is very, very much maintained and based on the contributions from the community. So let's take a quick look at starting with Sitecore containers using the Docker images repo that we can find on GitHub. When you download it, there's various sort of PowerShell scripts to help you get going. But the most simple one is, the one that you could use for a very quick start is build.ps1, very simply named. And all you have to do is provide your Sitecore username and your Sitecore password. So that's the password and username password for dev.sitecore.net. So what's this going to do? So this will go away to dev.sitecore. It'll download all the WDPs, all of the things we need to start building these images. It's going to build all of the containers plus all of the variants inside the Windows folder. We'll talk a little bit more about that later. It is going to build a lot of images. You do need a bit of room on your disk to make sure you've got enough space to put all of these. And it's also going to base all of these images on Windows Server 2019 LTSC, which is the long-term support channel version, which if you're up on your Windows kind of versioning, it's 1803 as that sort of base image. Those images that we generate are stored locally unless you provide a registry, a private registry for you to do. You can provide that inside of the build step. But if you're just starting out, don't provide a registry. It will store those in your local instance of Docker and you can work with them from there. Right. We have a very friendly MVP popped up, and this is Jeremy Davis, and he's going to help us with any of those other little things in the style of Clippy. He's going to come along and explain to us if we need any tips or tricks. So the first thing he's going to tell us to do actually is that when you build those Docker images, the machine that you actually build them on is really important. If I build them on a 1903 machine, Windows 1903, and you can go into your settings and check what version of Windows 10 or whatever that you're running, you won't be able to run them on an 1803 machine. It's to do with thread Hyper-V isolation levels and other things like that. So just be really careful about the machine that you build those on, and also where you're going to be sort of sharing these images to. If you're on the latest version of Windows 10, which will probably be 1903, the script that you'll run will build 1803 images for you, and they're all fine. You'll be able to share them, but it's just a little gotcha just in case. And obviously, angry Jeremy doesn't want you to push to public registries. Obviously, these are Sitecore images, and if you're starting to put in things like license files and other things, just be really, really careful you're not pushing to Docker Hub, else you may get in trouble with angry lawyers or other things like that. So once we start building those things, it takes about 2 hours in all of to do all of the process. It's extracting all of the things from the zip and the WDPs, creating all your SQL databases, doing all the sort of magic that it needs to do, and it goes through and it creates all of these images. Now you can see there's actually quite a lot of these, but this is looking at things like you're getting full topologies for XM, XP. You're also getting what's called like variant topologies, which are JSS, XM for JSS, XP for JSS, XM for SXA, and XP for SXA as well. So there's a lot of images in there. Now you don't need to build all of these images. Like I say, the build script, the build.ps1 will go and build all of these for you by default. You can actually select the ones you want to run, and there's information on GitHub about selecting that. But I wanted to see how long it took to build all of them, and on my machine it took about 2 hours, which wasn't too bad. Just have a longer lunch or something like that. It'll be fine. So, Jeremy's here again. So also you'll find that in the process of building these images, there's also a lot of what they call intermediate containers. So where we're copying things from one to the other before it builds the final image, you'll find that you have these intermediate containers. And when you do a Docker image list at the end, you'll have these little containers which are sort of marked as none. Now they're just kind of junk cruft. And if you use Docker image prune -f, it will clear those out and it will just sort of tidy things up. I think on my local machine, I saved about 12 gigs of space on there. Like I say, it's worth having a bit of disk space when you're building these things, like I say, because these images are quite large. They're not as large as they're saying on the screen, because if you imagine the Windows base image is shared between them, and we'll explain a bit more about layering as we go on. So how do I start running these containers? Well, obviously we need a license file. Sitecore is a licensed product, so you need to actually point and set an environment variable called license path to the location of where you have your license file. As simple as that. So download your license file, put it in a directory, and set the environment variable. Then we're going to use something called Docker Compose. Docker Compose, if you know, is like a feature. So instead of just starting up one container, we're actually wanting to start up a set of containers. Now, depending on what topology or what variants you want to run, you're going to be using different Docker Compose files. Now, those can be found in the Windows tests directory and 9.x.x. And you'll have different Docker Compose files for whether you want an XM, an XP, SXA, JSS, etc. And you just tell Docker Compose to bring those things up. This is roughly what a Docker Compose file sort of looks like. And if we break it down, all it's really doing is saying, I'm going to set up 4 services. So this, for example, is the XM topology. So I'm going to bring up a SQL instance, I'm going to bring up a Solr instance, I'm going to bring up a CD server, and I'm going to bring up a CM server. So this will give me my XM1 topology to work with. Also, you can see inside of here that it's actually setting some ports to run on for each one of these. So if you do have local versions of SQL Server running or Solr or IS running on your local machine, these will now be mapped to different ports so you don't get any sort of clashes between them. And that's really, really important. We'll go into the details of all of the parts that make up the running of these containers and why we need things like ports and volumes and other things on there. The last final thing to understand is, if you can see, the CM and the CD server have these links to SQL and Solr, and all that means is when it starts up, it's going to start SQL and Solr up first, and then it's going to start CM and the CD servers. It just means that obviously we need SQL to be running before we can start running on our CM and CD servers. So now we're going to talk about how we adjust our mindset containers. So we've taken the Docker images, GitHub, we've built a load of containers, but why are we doing certain things, and how should we be thinking about containers, and how does this differ from our sort of normal processes, and how are we going to change our current processes or achieve the same things that we're trying to do day to day, both from a sort of a developer point of view, local development, I'm working on my application, to how am I looking if I want to deploy on these containers to somewhere else. So the container has a name of a container because, just like a shipping container, you have to try and think of it as a sort of sealed box. It's your whole application or whatever in a contained form. And you can have multiple of these and you can layer them out. But they also, you know, in sort of programming terms, you need to kind of think of them as sort of immutable. The idea is they are sort of unchanging. You know, they're a snapshot of your application at that point in time. And then what we need to do is, over time, we need to make modifications to the containers to be able to get information in and information out. So one of the examples is passing in environment variables to change various parts of the configuration. Now, traditionally, you would probably edit a file on the file system where you were talking about, you know, you want to set a value, a connection string, et cetera, In the container world, these are normally done through environment variables. And it just means that as I make more and more copies of the container, I can use that same environment variable across them. And I don't need to go into each individual container and, let's say, edit the file and so on and so forth. And the same with ports. As you saw where I brought up the Docker Compose file, also the internal network of where a container is hosted is very different from the external. And you need to kind of punch a hole in there and say, well, actually, my web server is running on port 80 inside my container, but when it's on the outside world, because I've already got something running on port 80, I might want this running on port 8080, and you need to map those things. And then finally, the other most important thing really is talking about volume mounts. And these are really a way to sort of get data in and out. This starts when we sort of talk about doing persistence. If you start a container up, make some changes to it, it's going to allow you to do that. It's not like you can't write to it or anything, but if you shut that down, start it up again, all of those changes will be lost. And obviously that's not ideal in some situations, like building, if you've got a SQL server running in a container or other things like that. So we'll talk a bit more about how we can enable persistence, and that is through the use of volume mounting of things, having things locally and mounting them inside of your container. The other thing to talk about is layering. We were talking about the sort of Windows image and the other things that we need to do. And when you think about containers, you have to think about them in terms of layers. We're taking a base layer and we build on top and on top and on top. So let's take a web app, for example. Our base layer is always going to be Windows, in this case, Windows Server 2019 LTSC. But if you think of the next layer up, I could just take the Windows Server, and if I wanted to do you know, something with it, I can just work. But I need the net framework. So the next layer on top of that is the net framework and IIS that I need to have installed inside of it. And the same is if I'm trying to spin up a SQL server as well. That will have a sort of similar base, but the next stage in that process will be through to the installing the SQL server on top of that. Then you add the Sitecore layers, Sitecore 9. You know, the files inside your bin directory or your WW root gets installed into there, whereas over on the SQL image, you're then layering on top web master and core databases. Finally, what you'll find is that your application files come next, and it's really important to look at the separation here, because we've got two containers, one for the web and one for that same application, but the SQL part. So while you're looking at config files and DLLs and everything else that you need to make your application run on the left-hand side, having your data in some sort of form. So the traditional way would be to spin up the CM server and install a package or whatever. But in containers, it's slightly differently. You have to think about things in terms of installing your data directly into the SQL server. So you're looking at transforming item data into things like DAC packs and other things like that, so that when you build those layers up, you can apply those things. So you can assume that the Sitecore database layers are on there, then you apply a DAC pack, which would have your application data in. And it's this kind of subtle change in how we do things that you might not be installing it through Sitecore. And also, you want to shut down your container, you want to bring it back up again exactly in the state that you left it before. So there's not going to be any moment where you're installing the package or other things like that. You need to look at the state after it's been installed. So there's various questions that get asked when we start working with containers. Main one is, how do I persist data with a container? And like I say, the idea really, the most common way is through volume mounts. And all this is this idea that I have my local machine or a server somewhere that I'm running my container on. And all I'm doing here, so this is a little snapshot of the section in the Docker Compose file, is I'm saying, well, actually, I'm going to mount C/data inside my container, and I want that to be mapped to a folder on my local machine or my server or whatever. And it means that the MDF, LDF files that you would have in this example, because we're talking about a SQL server, those are the things we want to kind of write to. They'll be mounted into that directory, and actually they're saved and worked on that local machine, on that server, instead of being saved inside of the container. And this means that if I power down that container and bring it back up again, it's going to have that same mount point, in which case it's going to mount and use the MDFs and LDFs that were in that directory, which means the changes are persisted. And this is just a sort of common way of sort of taking data or things that you want persisted between sessions. And this allows us to have effectively quite nice things that you could actually upgrade the version of SQL Server that was running. Let's say there was a security patch or something. You don't need to move the data. All you need to do is update the base image. Next time it starts up, your data's still going to be in the same place and will get loaded in the next time it runs. So that's just an example of how to kind of do persistent. And volume mounts are really interesting. I mean, you can mount configuration, source code, other things that you might want to be working locally. I mean, it very much it depends on the situation. Oh, there's Jeremy again. And it is, yes, it is very important that you can't mount single files. I remember pulling a lot of hair out trying to wonder why I couldn't mount the license file or a single file into there. The mount points for these things are the whole of the directory, which adds some sort of interesting things. If you imagine you're trying to mount, you can't really sort of mount if you had your application config directory, your app config directory, if you try to mount that, like to get one file into it, remember it's going to take over that whole directory. So a lot of the time, sometimes you want to park things outside of there, mount somewhere else, and then copy them in later. And this brings on to how I get my code into the container as a developer if I'm using a container as a development tool, because they are extremely useful as a development tool. I can spin up a container containing 9.2 or 9.3 or different versions or different branches of the code potentially. And it means when I shut them down, I don't have databases hanging around on my computer. I don't have Solar instances and other things that might sort of generally clog up my computer. So it's using a container in the best way it can. So the general workflow for when I'm sort of developing with this is looking at, let's say you've got your customer's code or your code inside a Git repo, and the idea is you're kind of going to do something like a Visual Studio file publish, which will take everything and put it into a certain directory. And you'll see now that what I'm going to do is take a volume mount and mount that to C/src. Now, why didn't I just map that to www? Well, the interesting thing is if I did that, I would need all of the Sitecore directories. I might have other things that are in there to all be available in that deploy directory, and it all just gets a bit messy. So a better way to do this is move the deployment code into there, and then the community has a really nice PowerShell script which uses robocopy called watch directory. And you can set the watch directory up so that when the container is running, it will constantly look at a directory, and then any changes in there, and only the changes, will then be moved to the www root. And obviously, as we know, if you change a file in there, the application will reload or whatever. But it's a really nice sort of developer workflow that as I'm, publishing things out locally, it will then get moved over to the container, and I can see that. And I have a sort of seamless sort of developer experience as I'm moving the differences in. And it's, like I say, it's that very slight change in sort of mental process that you need to have to understand, why things are happening the way they are. Equally, so I've deployed my code into the container, and now there's something wrong with it. Of course, we all code without bugs, so I don't see why we'd ever need this. But if we do need, for some crazy reason, to attach a debugger to it, we can also do that inside a container. So the entry point to a container is the first. So when the container starts up, it is the first command that it kind of runs. Sometimes it's in a Windows container, it'll be something called service monitor, which monitors the W3P process and keeps the connection alive and the container alive while doing that. When we debug, we want to actually use the Microsoft Visual Studio monitor, which is the remote debugger tool. And that means that when we connect to it, we're actually then connecting through the remote debugger port, which is 4024 for Visual Studio 2019. And it means that I can connect my local Visual Studio to the remote debugger and then sort of debug my code on the fly. You can see there I've mapped port 80 to port 8080. So if I go to port 8080, view my web page, if I then hit a breakpoint that I've set in my Visual Studio, it will connect through there, and we'll be able to start debugging our code. Now, Mark Cassidy, who's one of the MVPs, has a good blog post on how to get this set up and running, and the community project has a nice entry point script to help with this as well, which we can talk about a bit later. Yes, and it is important to note that different versions of Visual Studio, for some reason, I don't know why, but they have different remote debugging ports. So I think Visual Studio 2017 is 4023 or something like that. But go on the web and just check that you've mounted the right port based on the version of Visual Studio you're running. And also, remember to build in debug. If you don't, you could wonder why your breakpoints are not being hit and other things. When you do that deploy to that thing that is pushing your source code across, make sure that you're pushing across those debug DLLs as well. So another thing to check is, get asked to do is, how do I check the logs of my application? In a usual scenario, I can just open a folder on my local machine and see those logs. Now, you could have that exactly the same thing. So we could go back and use the volume mounts to take the WW root app data logs folder, and we could mount that to a folder locally. So as I'm working, I will see those logs appearing in there. Absolutely no problem with doing that. It's a nice, quick, easy one for a sort of local development environment. But Docker themselves, and also if you're using an orchestrator like Kubernetes, they have a feature or a command line tool called logs, and you can basically do Docker logs or Kubernetes kubectl logs, and then the ID of the thing, and it should be able to sort of spit out the logs into your local sort of console session. And how that works is it reads from the standard out of the application. Now, the problem is Windows containers don't output to standard out. And it's a real problem, and Microsoft are working on it, and they've just announced something recently that they're going to open source something that's going to solve this problem. But for now, we have to work around a problem, and we want to be able to get the logs out into standard out. And how we're going to do this is by looking at the log4net settings that we have in any Sitecore installation. So by default, they're set to what's called the rolling file appender. It writes to a file every night, flips over, writes to the next day's logs, and so on and so forth. What we want to do is swap that out for the UDP appender, UDP being a port like TCP, but we're going to modify it so any logs that Sitecore is writing are going to be writing to a local port. And then we're going to use a little application called FileBeat. FileBeat's a really, really tiny thing. It's just a little sort of log shipping application from Elastic. And all it has is the concept of an input and an output. So we're going to take the UDP, it's going to listen on the UDP port 777 in this example, take the logs from that port. It's also going to look on disk for the IIS logs, and it's going to read them in, and we're going to set that to set the output to console or standard out in these terms. So this then gives us that great ability. So if I do Docker logs, then the name of my container, I can actually see the Sitecore logs. If you're running Docker Compose with the logging set to like standard, if you're not running it in background mode, if you're getting all of the foreground stuff, you'll see the logs in there as well. And it's really, really helpful in a sort of container environment to see this information. But the great little thing about FileBeat as well is it supports other outputs. I mean, console is just almost like a yeah, side note, but it supports outputting to Kibana, to Logstash. You can output to Redis, and you can even output to Kafka if you want. And it's a really nice way of looking at how you can, ship your logs out, so you can get everything from the container and move it to somewhere else, so that you can, keep an eye on your information over time. The community project also has a nice entry point to get all this sort of set up for you. So it's a weird thing with Windows containers that we have to work around, but it's also a nice solution. It also means that because we're not writing any logs to disk, nothing is getting written to that container. So we're equally going on the fact that that container is a sort of immutable thing. We're not really writing data to it for no reason. We're not increase the size of this thing if we don't want to. So if we're shipping the logs out somewhere, it means that our data is going somewhere useful. One thing that is quite common in sort of containers is sensitive information, what is known as secrets. If we look at our application, we've got all the different layers that build up our app, but what are we going to do with things like passwords, connection strings, all of this sensitive information? The danger is that you would bake that information in. If you commit a config file into your container and it's got the name of your password in, if you then give copies of that container out, you are giving out also copies of that password. If you are setting a security certificate, you are passing out that. Now that may be what you want, but most of the time it isn't, and you want to be able to pass those things in at runtime. So again, we're back to looking at environment variables. So taking, let's say, a connection string for SQL Server and storing that. So you can store things inside of Kubernetes secrets, inside of Azure Key Vault, or inside a third-party vault like HashiCorp Vault. These are all available on the cloud, or you can run locally. What it means is when the container starts up, it will take that from that vault, whichever vault or secrets store that you're using, and mount that either as an environment variable, or it can actually, some of them can actually mount that as a file on the file system, and then you can sort of reference it in. But it's really important to think about how you manage your secrets and how those things are passed into your container at runtime. So how do I monitor my application inside a container? So monitoring is obviously a really important part of the whole DevOps process, and a key part of that is kind of what we call observability. It's being able to kind of get information in and out of your solution. Like I say, here the quote was, it's about being able to ask arbitrary questions about your environment without having to know ahead of time what you wanted to ask. You're always getting a stream of information out of your application, so you don't have to log in and see what it is going to tell you ahead of time. And there are 4 pillars to observability, and I thought I'd use these guys to help me illustrate that. And we have logging, we have health checking, we have metrics, and we have tracing. I hope everyone knows who this is, otherwise I'm just too old and it doesn't matter. But these are the sort of 4 parts of observability that we want to have running throughout our process. I'm going to talk, I've already talked about logging, really, really important, and also the idea of shipping the logging out somewhere else. But I'll touch on health checking and metrics. Not going to talk about tracing today, and maybe on another talk I can. But really, how do I want to check the health of my application? So if Murdoch is wanting to use my application, the idea of putting something into a container is that I could actually scale it out. And once we're scaling it out, we're probably running behind something like a load balancer or an orchestrator that has a load balance function inside of it. And what I really want to know is if my application instance breaks, if it's on fire, if it's no good, I need to be able to give information to the load balancer to say, take that out of the load balancer, send all the traffic and all the people to the other instances while, I put out the fire on this other instance or whatever else. Another interesting one is not necessarily complete failure, but also having an instance that is degraded. Let's imagine something like a Cortex process or something like that, where you're doing a long computational piece of work. It could be that one of the instances is just simply busy, and so it would be nice to be able to sort of signify to your load balancer that, while there's nothing wrong with it, it doesn't need to be restarted. You might want to send the traffic to somewhere else. The common way to do this is with a very, very simple page, which we call health. Well, I call it health Z. You would probably call it health Z. and it's just a simple page that returns a HTTP status code. So if there is a problem with the site that I can see and monitor, I can return a 500 error as my HTTP status code, and I know that that thing is unhealthy. And it's a very broad brush, but it really helps in things like load balancers and other situations to be able to say, please leave this instance alone, or take it out of the load balancer, or even in some cases, please restart this instance because it's not healthy. And similarly, you can provide other HTTP status codes to the load balancer or to your other application that is going to be able to tell you that that system is in some way degraded, or paused, or busy in some way. Kubernetes, for example, takes this into a sort of a little bit more specific things, and they have this concept of liveness and readiness. Liveness is your application is up and running. So I don't care about any sort of dependent services or anything else like that. As long as I can kind of get to it, I suppose you'd think of it like if IIS was running and I could return an IIS page. Whereas readiness is the app is up and running and ready to receive requests in terms of, are all those other dependent services ready? So for Sitecore, that would be things like Solar and SQL. And those two are quite different, because if health.z live is down, then you probably want to blow away that container and start it again because something serious has happened. Whereas with readiness, you might be saying, well, actually, I can't connect to the SQL server at the moment. You might want to look at it, or you might want to, try again in 30 seconds, try again in 60 seconds, and so on and so forth. It tends to be less catastrophic, but maybe there's something about the liveness check was failing. And so there's sort of, subtle differences in how you have those sort of health check probes. But generally, if I want to get more details about the state of my application, we're then going into the realms of metrics. And metrics is the idea of tracking time series data. So taking a snapshot of the application and various sort of values and other things that it's doing over time. So we can see here, face will change his appearance over time. So we want to track that and see that over time, because we want to be able to sort of snapshot, move across, snapshot, and then you have what's called a time series database, which is going to be able to sort of check the differences between that, and you'll be able to take that information and start to do graphs and time series models with it and other things like that. And it really gives you an idea of your application over time. The general way to do this is what's called with a format which is based on Prometheus. Prometheus is a time series database, but the format of this is extremely simple. So this here is just an output from Docker itself, which outputs metric data. And you can see here that we have various containers. 0 are paused, 3 are running, 7 are stopped. And that's a snapshot at that point in time. Let's say, a minute or 2 minutes, 5 minutes, whatever later, I'll take another snapshot, and maybe I can see that 5 are running and 12 are stopped, or anything like that. But because I'm taking that snapshot, I can then start to build a graph and see a trend over time. And it's the fact that the idea with observability is that you're seeing changes running over time. And in a sort of closed environment like containers, it's really nice to have your data being output. You're not logging into the machine as you would normally imagine to do to investigate things. So you're wiring these things into other services. Another thing is the idea that you might actually, why aren't we taking this data and pushing it somewhere? Well, actually, that puts the pressure on the application. So the application is, using computational cycles to push this data, and it has to, connect to another thing. And what if that thing is down? So you really want to sort of flip this on its head, especially for sort of metrics connections. So Azure Monitor and Prometheus are the main sort of places. So Azure Monitor can read Prometheus output data. And what you do is you set those up to read from that metrics endpoint at particular intervals, 1 minute, 10 minutes, 5 minutes, whatever. It depends on how much you need. And then you can start using tools like Grafana and other things like that. And obviously, Azure Monitor has its own, sort of graphing engine and can pull things into App Insights. And you start to be able to see the difference in those things. So generally, there are 4 sort of types of metrics counters, obviously increasing over time, and then will get reset when the process starts. A gauge, any numeric value, you can see here on the right-hand side, I've got different gauges showing up here. A summary, which is tracking trends over time, and then sort of histograms and event buckets and other things. And all in all, those give you really nice output. There's a good open source project called Prometheus Net, which works for C#. also can take things like low-level .NET functions like memory, CPU, garbage collection size, all of those things, and it can map those into a metrics endpoint for you. And so you start to push out your data and make your application more observable. So when you're in this containerized state, it's really, really important. You're shipping your logs. You're able to interrogate that application to see the health of it. Is it healthy? Is it working? Can it connect to all the things you want? And then going into more detail, which is what are the metrics? How big is my queue size? How much memory am I using? What is the CPU using? And because you're collecting this stuff over time, you're not stressing your application out by delivering that. You're just sort of snapshotting. You're not having to log into it. So it's really, really important. Tracing, which is the fourth one, takes that a little bit further, and you start to get output from your actual code paths and starting to trace things between different services, but that is a talk for another day. Right, so what we're going to do now is talk about what's new inside the Docker images repo. There's been lots of contributions from the community and various people pulling together different bits so that we have a really, really nice starting point for anyone who wants to get going with sort of Docker images. So the first thing we did recently was remove SIF for building. Previously, we'd download the WDPs and then we'd use SIF to actually construct the base images inside of Windows. Really, for containers, this sort of isn't needed. It actually simplifies the process if we don't have SIF, because we don't need a lot of extra prerequisites, and it means we can actually reduce the number of layers that we have in our container images, which is always good. So what we call no SIF now is the sort of default way to sort of build our images. The other really, really interesting thing now is we've actually added support for Sitecore Commerce. So now we're starting to have Sitecore Commerce images as well. Obviously, with anything like running a full XP1 topology and running Sitecore Commerce topology, there are lots and lots of different processes and roles running at the same time. So running them inside Docker and inside a compose file can be really, really useful for running locally. So thanks to Juiced for contributing that, and work continues on these things. They'll be further optimized, and then we'll probably have variants like we have SXA and JSS together. We'll also have probably things for Sitecore Commerce with different storefronts and other things. But it's all very much dependent on the community. So if you're interested in Sitecore Commerce, please dive in and look at the options there. And if there's nothing there that you want, or you think it should be changed slightly, please raise issues and help development of that thing. The other one that I've talked to, I touched in various points of the presentation, but was about these entry point strips. Obviously, the entry point is the first thing that when the container starts up. And having an entry point script that does different things for development and production, you don't have to have it, but it can be really useful. So there is a development entry point script, and what that'll do is set up the Sitecore logging. We were talking about the UDP appender and the file beat, and then that will output really nicely to standard out. You can also enable it to do the file watcher, where we were talking about moving our source code in and having it robocopy the changes into the correct directory. That'll all be set up for you. And like I say, remote debugging, which can be a little bit of a pain to get going. So again, another great use of the community is to have those things already set up for you. What development doesn't do out of the box, because we were in discussions and we decided that it was sort of a little bit too much, was show the IIS logs. And so we have a production one which allows, which does also the Sitecore logging plus the IIS logging. We don't need the watch or remote debugging on that one. But it's all enableable, disableable using environment variables. So, if you want the IIS logging in the development one, you can just pass in an environment variable and enable that. So just those are the defaults we've gone with sort of out of the box. And it really is a testament to the hard work from people like Per and Bart and Juiced and all the other people who are contributing to the Docker images repo and testing all these different things out and making sure that we have the best sort of solution to get people going. So I wanted to say thank you for them for all the hard work they've been doing. So now it's time to talk about containers in 9.3. So I think if people remember back to the sort of end of September this year, Sitecore had a lot of kind of feedback from customers saying, we really, really want to get going with containers. But the thing that's holding us back is that you guys say you don't support the product when it's running in containers. And a lot of the time that, you could replicate the bugs in there, but if it was running in containers, you had to take it out of the container and then, test it on a local instance, prove that bug was still the same, and then support. So To get to sort of accelerate and get people going with that, at the end of September, we've said now we will support your site running inside a container, and we'll do our best the Sitecore support will do their best to help you in that environment. Obviously, we're not saying that we will help you create the containers or develop with containers, choosing all of those things, that's still down to you. But if you do have a support ticket and your thing is running in containers, we hope that will unblock certain customers. But what we really wanted to do was take that further. And we really wanted to make it so that when you were running on containers, especially when you were building with containers, that all of the things that I've talked about today, that we were sort of help enable those things. So again, we're not supplying container images, and I'm not telling you how to run them. That's something you need to do with your Sitecore partner. What orchestration engine that you want, how you're going to deploy your application onto them, and all things like that. But what we do want to do is bring in feedback from the community. Working with the Docker Images repo, we've learned a lot. We've done internal demos and testing with containers, so we're learning a lot all the time. And also, we wanted to make sure that any changes we made were consistently rolled out across all roles, which means CM, CD, and XConnect, and all the different services in there. So the very first thing that we changed was enabling configuration via environment variables. It's a really tiny little change, but it's so important when you're running in containers. We enabled this thing that was actually part of .NET as part of 4.7.1, the full framework. Introduced these things called config builders. And so you add a little section into the web config and define config builders, which will look for environment variables prefixed with a certain thing. See here, we're looking for the prefix Sitecore_app settings or Sitecore_connection strings. And what that means is we can decorate the connection strings part of our connection strings file with a config builder. Now, this is really, really cool because it means that when I start to build my Docker compose file 4.9.3, I can actually start, instead of having to, because previously we have to take the file, we have to patch the file, do these transformations and other things just to get that information in. It means that I can start passing these connection strings in via environment variables. And that's really great if you've got a Vault, Azure Key Store, Key Vault, or HashiCorp Vault, or any of those other ones, which means you can have those controlled in a separate, more secure place and pass them in at runtime. You see here we're setting some connection strings, and then we're also setting some app settings. And this is really awesome because basically the default behavior remains exactly the same. If you're happy to use configuration files, it's fine. Adding that configuration builder part doesn't make any changes. But if you want to supply them via environment variables, it will check that first and use those. If not, it will go back to using the ones that are on the disk. And so this means no more patching and transforms inside of our Docker files, and it just means passing things at runtime is really good. Also, it means that we can share values between container instances because, let's say, the connection string to the web database, I can use the same one between between the CM and the CD server and other roles that were in my system. And it just really sort of helps make everything clean. A small change, but really, really sort of useful and speeds everything up and is the proper sort of container way to do things. It's worth pointing out that Sitecore has actually supported environment variables inside its configuration for a little while. It is also worth to note that if you do use this with the $env pattern that you can see here, that is not providing a default value. So if you do not set that value will be, if you don't set that environment variable, that value will be blank. So just be really, really careful of when you use that. That is different to the config builder stuff that we have for connection strings and app settings. The next thing is passing in the license file. Normally how we do it is take the license file and we'd mount that onto the file system. Still absolutely no problem to doing that. But for 9.3, we really wanted to sort of, help with that. And so now you can actually pass in the license file as a whole into Sitecore as an environment variable, which is great. The only problem we ran into is that the license file is 90,000 characters, which hits the Windows environment variable limit. And so we've taken the choice to gzip that and base64 encode it. So in order to pass in the Sitecore license via an environment variable, you can just take your file, gzip it, base64 encode it. That gets it down to about 14,000 characters, which doesn't hit the limit of 32,000 characters. If you don't want to do that, if you don't want to pass it in via an environment variable, you can actually now set the Sitecore license location. So if you're mounting this as a volume mount, instead, previously you had to set a patch. You had to create a patch file that told Sitecore where that was. You don't need that anymore. Just set Sitecore license location as an environment variable and tell it to go to C/license, for example, and it'll work like that. We're also giving you health checking out of the box. So we're giving you the Health Z Live and the Health Z Ready. Health Z Live will just check the application is up and running, and Health Z Ready will run through a check for all of your SQL Server connections and all of your Solar connections. So you'll be able to monitor your the health of that application externally as well. The other thing we looked at was running Sitecore in what's called a sort of behind an ingress. This means in that kind of load balanced environment in Kubernetes or other sort of orchestrators. Sometimes if you're doing SSL, you're actually using what's called an ingress. So some people put Nginx or some other sort of ingress controller before it, which does the SSL termination, which means from the public's point of view, I'm going in as SSL, but then internally it's pushing you off to various different servers. Now, what can get complicated is if those servers are also running SSL because they need different certificates and other things like that. And so it is actually easier in those situations to turn HTTPS off for those second layer servers. So in this example, the CM server, the CD server, and identity server. So we've made changes to enable us to turn that off easily. So if you are doing SSL termination and an ingress, it just means that you'll have less of a problem in there. Now, this doesn't mean that we're turning off security or anything else like that, but you will find in a sort of containerized or orchestrated environment, the sort of best practice way to do SSL is using a service mesh. And the service mesh will inject what's called a sidecar, which will give you unique keys between each input and output of your container, which is incredibly complicated and very tricky, but the infrastructure manages that for you and it makes it even more secure. But weirdly, you need those servers to not be running HTTPS. You need it to be done by the infrastructure. And so having the ability to turn that off is really, really important. The other thing to have in there is the idea that, yes, if you are running in an orchestrator or you're effectively running in a load balanced or a proxied environment, we need to be handling different forwarded headers. So you've got X forwarded host, X forwarded protocol, X forwarded ports. And so if we enable the load balancing config, which you see here, we actually will honor forwarded headers and make sure that we return the right URLs to there. So really, all in all of these parts of the application, all of these changes that we've added into 9.3, while some may seem as small, they actually make a really big difference when you're running sort of in containers. So I was really pleased to be able to get those things in and have those added to 9.3. So it will make everyone's sort of container experience of running those things really a much better experience. So with that, I want to say, thank you for listening right to the end of this application. Hopefully you can see, the slight mindset change that you need to work with containers. It's not vastly different, but sometimes these little gotchas can get you. I will advise everyone to go and check out the Docker Images repo and see all of the good stuff that's going on in there. Please contribute if you think you can take part in the, any issues that raise, because getting a consensus and opinion is really, really useful. And I hope you really like the changes that we made in 9.3 around containers. And watch this space for more information as we do that. But thank you very much.